Good day, students. Welcome to the Microsoft Academy. Now we have a question on electromagnetism. This is under DC circuit, direct current circuit. Now we are looking at a galvanometer that has a coil of resistance 5 ohms and then gives a full scale deflection with a current of 10 milliampere. Now how may it be made into an ammeter reading up to 10 milliwatts ampere? So now what we want to do basically in this question is to convert the galvanometer to behave like an ammeter, and in doing that we'll be needing a shunt. A shunt is a resistance or a material that have low resistance. So if we place it in a proper way parallel to the circuit, we are going to see that it will produce the ammeter of such value. So let's go. How do we do that? We have said that the shunt is placed parallel to that of the galvanometer. So what it means is that the same potential difference in the shunt, the potential difference, so I'll use PD to show the potential difference in the shunt, is equal to the potential difference in the galvanometer. So when we talk about potential difference, we are looking at the potential drop, which is given as V equal to IR. So for the shunt, I'll be having this potential drop in the shunt will now be IS, then R S from the formula, and it will be equal to the potential difference in the galvanometer as IG all over R G. Now what we are trying to get is to get the resistance of the shunt, because we need to know what value of shunt resistance that will help us to do that conversion to get that maximum current. So making Rx the subject formula, we are going to have here that Rs is going to be equal to Ig Rg all over Is. So that is the value. So from our question, you can see that in the question we are given the resistance of the galvanometer. So our Rg is given as 5 ohms, and also you can see that and it gives a full scale deflection of the current of 10 milliampere. That is the current of the galvanometer as 10 milliampere. Now when you talk about milliampere, what we are looking at is 10 times 10 raised to power minus 3. That's the conversion of the milli, means minus 3. Then we have ampere. Okay, now we have gotten this, but the problem is, what is our IS? So if you look clearly, you will see that we don't have the IS from the question. Rather, what we have is the maximum current made into an ammeter reading up to 10 ampere. Okay, from the question here, this is 10 ampere, not 10 milli. So that is the maximum current. So what we have in the current, we have the maximum current as 10 ampere. Now from our relation, we have that the current in the shunt plus the current in the galvanometer is going to give us the maximum current. So which implies that I can get the current in the shunt by simply making the current in the shunt the subject formula. I have Im, then this guy move over to this place, you have Ig minus Ig. So you can substitute, you have your maximum current as 10 ampere, then you have the current in the galvanometer as 10 times 10 raised to power minus 3 ampere. So if we do the substitution from our solving, we got that this is 9.99 ampere. So that is the current in the shunt. So going back to the formula, we can now see that our Rx is equal to Ig, which is 10 times 10 raised to power minus 3, then multiply by your resistance in the galvanometer, which is 5, then divide by the current in the shunt, we got as 9.99. So if you punch this in your calculator, you are going to be having the answer as 0.005 ampere. So that means the ohms, this is the resistance. So that means the resistance in the shunt is 0.005 watts ohms. So that is the required resistance to convert the galvanometer into an ammeter that will read up to a value of 10 watts ampere. So that is how you solve problems on this galvanometer to ammeter. Then in next question, we are going to look at how we can convert the galvanometer into a volt-watt meter and some questions that are related to that, because these are questions you see in exam. Thank you.